Okay, we are on page 5 of your notes. We're going to talk about parallelograms and the definition of a parallelogram. So I already wrote it down. A parallelogram is a quadrilateral, so it has to have 4 sides, with both pairs of opposite sides parallel. Okay, so to remind you, to mark that something's parallel, you put arrows in the picture so that the two things that are parallel have the same markings. So these are parallel, they both have 1 arrow on them. And then I could put the top and the bottom are also parallel, but they would need a different marking, so you'd have to use 2 arrows or 3 arrows. Also, we are going to name parallelograms, which we've kind of already done. I use M, A, T, and H to label the vertices of this parallelogram, so we could call it parallelogram. You just draw a really small little parallelogram, M, A, T, H. You could have called it ATHM or AMHT. As long as you start at one vertex, go either way, clockwise or counterclockwise, and you name every vertex you touch as you go around. You can't name it TMAH because that draws an X. And in our parallelogram, we have sides AT parallel to MH and AM parallel to TH. Okay, so we're going to use these symbols for parallelogram and parallel often in this part. Okay, so then we have a few theorems about parallelograms. The first one is that if you have a quadrilateral that's a parallelogram, then the opposite sides are congruent. Okay, so that means that the sides that are on the opposites have the same length. So you could mark that as these two are the same, and then the top and the bottom are the same. Okay, you have to use different markings because the top and the bottom are not congruent to the left and the right side, so we have to use 2 markings for those. Okay, then the next one says if quadrilateral is parallelogram, then its opposite angles are congruent. So the opposite angles would have the same measure. So opposite angles means that if I took this one here, that angle has 2 adjacent angles. That would be both of these. But the opposite angle is the one over here that you could draw a diagonal to. Okay, so those are the same. And these are the same. Okay, perfect. So in this next one, I'm going to have you use those properties to solve for x and y. So you have to figure out what is the relationship between the parts of the parallelogram that are labeled with x's and numbers. So looking here, 2x is in an angle. So 2x degrees because it's an angle. Okay, and we just learned that opposite angles are congruent. So I know this 2x doesn't have any relationship with 20 or 3y minus 1 because those are sides. 2x is an angle. Okay, but 54 is an angle, and these are opposite each other in that parallelogram, so those two are equal to each other. So you could set up an equation that's 2x equals 54, and then you divide by 2, and you get x is 27. That's your first answer. Okay, next we're going to look at the y. 3y minus 1 is on this side RS, and we just learned that opposite sides are congruent in a parallelogram. So 3y minus 1 is going to go with the opposite side over here. So those two will be equal to each other. So 3y minus 1 equals 20. And you would add 1. 3y equals 21. Divide by 3. And get y equals 7. Okay, so on the next one, we need to fill in the blanks in this proof. All the reasons are filled in for you. You kind of just have to think about what these reasons mean, and that'll tell us what to fill in over here, okay? So the first reason is given. So the given information is AK is congruent to MK. And they also told us that ABCD is a parallelogram. Okay, so before we move on, I'm going to try to mark this information in the picture. So AK is congruent to MK. I'm going to try to mark that this side of the triangle is congruent to this side of the triangle by putting that congruent sign in the middle. And I just have to remember that that congruent sign goes with AK and not BK. Okay. To mark that it's a parallelogram, I don't want to put too much in the picture right now, so I'm just going to remember that that's a parallelogram. You can put the arrows on the sides, but I don't know that there's nothing in here about parallel, so I'm not thinking we're going to need that. Okay, so the next thing says we have an angle congruent to something. I know it's got to be an angle here. I'm going to go ahead and put an angle sign because an angle has to be congruent to an angle. Angles opposite congruent sides of a triangle are congruent is the reason. So I look at my triangle and we mark that this side and this side are congruent, and I know that that means the triangle's isosceles, and this is basically saying in an isosceles triangle there's two congruent angles. Base angles are congruent. So those angles are this one down here and this one over here. So they said DAB, that's this one. So I'm going to call this one CMD. And you could have called it KMA or KMD, but I chose to call it angle CMD because I see up here we used angle CMD in the proof statement. So I'm going to try to get that into the proof. Okay, so the next step says opposite angles of a parallelogram are congruent. Oh, you know what? I'm going to go back to step 2. We need to put that in the picture. Angle DAB, I'm going to put one arc on that one, is congruent to angle CMD. So they both have the same marking. Okay, so then the next one, opposite angles of a parallelogram are congruent. So they named angle BCD, so that's this angle up here. This angle, its opposite angle is down here. We already have a marking on that one. So I want to make sure they have the same marking. So this one gets one arc as well. So BCD will go with angle DAB. Okay. So now the last one, I know the last step of a proof has to be your proof statement, but let's make sure it makes sense. The transitive property of congruence says that you have two things that are congruent to the same thing, and they must be congruent to each other. So step 2 and 3, we have two things that are congruent to angle DAB, so both of these have to be equal to each other. So angle BCD is congruent to angle CMD, which is what we were supposed to be proving. So remember, if you want, you can put a box at the end of your proof, or you can write QED. Either way, that means the proof is done. And we're going to do the top one here. This is just like the problem we did before. This is the practice. So see if you can figure out what x equals. You can use example 8 to help you if you need to. So pause your video, do this problem, and come back. Okay, so for this one, the x is on the side. We have two different expressions with x with them. They're both on its side. 127 is an angle. It doesn't have an obvious relationship with these sides. So that 127 is not going to appear in your equation. So I know that these two are equal to each other. So x plus 2 equals 2x minus 3. I'm going to subtract x from both sides and get 2 equals x minus 3. Then add 3 to both sides and get x equals 5. And that is it.